Hi guys, how are you all?
Hi, Miss Priya.
Hi, how are you? How was the break, by the way?
Good.
Good. Mm, okay. Did you have questions on the homework? Did you have questions on the homework?
Jingle bells, jingle all the way.
Guys, this is a question for all of you, right?
I didn't.
Mm, but we met after. Mm,
Miss Priya, it isn't a question like in the homework, it's about the homework.
mm-hmm. Go ahead.
Cause didn't you said do parts 1, 3, and 4?
Mm-hmm.
And 3, like it had like all the answers and everything. So
Really, see, let me quickly see that. Then it's a wrong
Well,
PDF. Mm-hmm.
I think number 4 I also did.
Did now. So let me check. See,
yeah.
I don't know, 2, 3 years back, I had one student who made a mess with the originals. I don't know. But anyway, let me see. If that is the case, I'll pull it out and upload the right thing. But if you have done it, it's okay.
Yeah, I just erased the answers and wrote my actual answers in.
Erase and all doesn't work. I'll do that for you. Wait. Because of the occasion, I didn't check. The original, I didn't check at all. But I just want to see where we are. Hold on. So it was on logical reasoning, right? Okay, all of you have submitted. Maybe next time when I upload it, I'll make sure you don't have those. Okay, part 1. Part 3 had the issue, huh? Which one had the issue, ma?
Part 3 and 4.
Oh, part 3 and 4. Oh my goodness. Okay. Part 3 and 4 had issues. Yes, I can see what is your issue. Okay. Okay. Noted, guys. I will, if anybody needs it, I'll update it from now on. But from now on, I'll make sure you don't have that like that as well. Okay. Can we go ahead? Did you have any questions? No? Mhm. Nice to see Vinisha and Ananya together. Let's go ahead. See, the pattern, right? Part 2, I wanted to work with you before assigning that. Let's see this one. Do you know how to, meaning, see, these are just extras. This is not required out of geometry to let you know, but then I just want to know. How about this? If I have a pattern like this. Johan, did you have any question? Harshita, did you have any questions on the homework? Randomly, I'm asking. Pratika or Shreya, did you have any questions?
No.
Homework was easy, right? Logical reasoning was easy. Dhruv, how about you? Both the Dhruvs?
No questions.
No questions because it was easy, right? Okay, let's see. I just want one. Okay. Suppose if there's a pattern like 1, 2, 4, 9. What is the nth sequence? Would you be able to find what is the nth sequence? What is the nth sequence? Would you be able to find, guys? Wait. Sorry. I move on. So what will you do for the nth sequence? Send it in chat. How are you enjoying India?
I just came in yesterday.
Oh, okay. Did you see my reply to my email? To your email?
Yeah, I saw it.
Okay. Good job, Johan. Avyukt, I'm asking for the nth term. Nth term in this sequence. How will you write the formula? Literally, the output rule for this nth term. Nisha, you really want the formula, ma? Input output table you have to come up with and find out the nth term. Ashruta.
Yeah.
Yeah, what is
Yeah.
the nth term?
For this question,
Correct, Shreya, you're correct. Avyukt, you're correct. Yes, for this question, what is the nth term of the sequence written in terms of n? Shall I help you guys for the first one, maybe? Dhruv correct. Dhruv Nayak correct. Pratika correct. Okay. What I'm saying is nth term of the sequence, right? Will be n square. I'm sorry. This is n. This is n square. That's all, right? If the input is n, what will be the output? I asked. 1 means 1, 2 means 4, 3 means 9, 4 means 16, n means n square.
Oh, so the answer is just n squared.
Correct. How about this? How about this? Mm, This is the sequence given. This is the pattern given. See, basically, this belongs to you have inductive reasoning, deductive reasoning, right? In logical reasoning, I told you about inductive reasoning, deductive reasoning. In that, this is a part of inductive reasoning.
Wait, Miss Priya, someone ring my doorbell. Can I go in? Should I go
Please
in?
go, ma. I've given you a pattern. Okay, so you have to form your own think about this is, let's say this is f of x or y. What is x? 1 to second term, third term, fourth term. Now the input is n. What happens here? First of all, don't worry about it. You don't need to find. Is this pattern before even you find out the nth term, right? Just see, is this pattern linear or quadratic? How will you find that? Or exponential? How will you find that? You all remember? This is from Algebra 1. How will you find whether a pattern is linear or quadratic? You guys have studied it. When will it be linear? What type of a sequence leads to a line? What type of a sequence results in an exponential series? Try to recollect, guys. I'll help you. The third one I'll explain. Quadratic I'll explain. I really want you to come up with what type of a sequence will give a line when you graph it. Algebra 1, definitely we studied. There was one type of line that generated exponential graphs. There was one type of sequence. What sequence generated exponential graph? What sequence generated linear graph? Yes, Harshita, that's right. Johan, good job. So guys, when you think about it, 1, 2, 3, 4, 5, 6. Let's consider this was f of x. X was 1, 2, third term, fourth term, fifth term, sixth term. When you graph it, this generated what? 1, 1, 2, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. What is this? So what type of sequence is this?
Linear sequence.
This is a linear graph, but what type of sequence is this?
Arithmetic.
Arithmetic sequence. They had a common difference. Arithmetic sequence had a common difference that produced a line. What type of sequence generated? 1, 2, 4. 8, 16. X will be 1, 2, 3, 4, 5. What type of sequence is this? And what type of graph did it generate? Let me show you. 1, 1, 2, 2, 2. That feels incorrect. Yeah, that's correct. 1, 2, and then 3, 4, and then 3, 4, 4, 8, and then 5, 16. What type of graph is that? What type of graph is that?
Exponential.
Exactly. So what type of sequence is this? What type of sequence is that?
Geometry.
Geometric sequence. There was a common ratio. Did you get it? So arithmetic sequences became a line. Geometric sequences became exponential graphs, right? Here, let's see what happens. This is a little different. Okay, this one, let me see. I'm going to erase what is not required now. Okay, but I just want you to remember there's no way you can forget this. Okay, because it will keep haunting you till you go to algebra 2 and beyond. Okay, arithmetic sequences give rise to a line. Geometric sequences give rise to an exponential curve. Okay. That's it. Now let's go ahead. So how about this? Let's try to find out how many dots. So let me write out the y again. 2, 6. What is this? 3, 6, 9, 12. This one is 20. Oh my gosh, I am not able to see a common difference. Neither a common difference nor a common ratio is in here. You know what I do and see? For this type of sequences, I'm not asking you, I'm just asking you whether it's a linear sequence or an exponential. Is it linear, or does it follow exponential model, or does it follow quadratic model? I did tell you for this sequence, for a linear sequence, definitely there'll be a common difference between the terms. It's none. For
Is
this model, Yama,
exponential.
you think so? Why? Times 3 times 2, no, right? You see
Oh,
what I mean? There has to be a common ratio. It isn't there. So it is neither an exponential nor a linear. But how to find it? You know what? For a quadratic sequence, this I have never taught you. This is the first time we are discussing. 6 minus 2 is a 4. 12 minus 6 is 6. 20 minus 2 is 8. The difference is not the same. But again, let me try to find out the difference. 2, 2. Aha, the difference is the same. This is called the first difference. When the first difference is the same, you call it linear. When the second difference is the same, you call it quadratic. Why? Because in this function, if the first difference is the same, it's a x power of 1 equation. Here it is a meaning, see, if you want to predict the nth term, right, it's going to have a square term, meaning, see, something related to here, let's see. This is 1 square plus what? This is 2 square plus what? Do you see what does that entail here? This is 3 square plus something. You see, this is 3 square plus 3. This is 2 square plus 2. This is 1 square plus 1. Do you see a pattern coming through now? This tells you, first of all, identify what type of sequence it is. It can be linear, exponential, or quadratic. How to say it's a linear sequence? If there is a common difference between the terms, it's a linear sequence. If there is a common ratio between the terms, it's a exponential pattern. That means, see, if it is linear, you will have your nth term as n plus 1 or whatever, n something like n plus 1 or n plus 2 or whatever, or n can be, or something like that. If it is linear, the power of n will be 1. If it is exponential, what would happen? 2 power of n or 3 power of n or something, n will be in the power. Okay. Whereas for quadratic, your nth term will have an n square term. Am I making sense, Harshrita? Okay. So your nth term will be a square term. So now let's see what to do. We found out that this sequence is quadratic. Now, how to find this? How to find the nth term of this? This is 1 square plus 1. This is 2 square plus 1. 2 square plus 2. This is 3 square plus 3. How to write out the nth term now? This is 4 square plus 4.
N squared plus n
N square?
plus n.
Oh, plus n. Yeah, it's so easy then. Yeah, correct. Got it? This is how, because see, finding this is hard. I won't understand how to find this. But when I see the type of sequence, I'll understand, oh, it's a quadratic sequence. My nth term will have a square value. You got it? Dhruv Naik, did you get it? Pratika, did you get it?
Yes.
Yeah.
Great. Okay, nice. Can I give you one more? How about one? What is this? 1 second, guys. How would, okay. Okay, let's see this one. Okay. I have an array, okay. 1 times 2, 2 times 3. I have an array. 1 times 2, 2 times 3. Okay. Then the next one is 3 times 4 and 4 times 5. 3 times 4. Then the next one is 4 times 5. Okay. In this scenario, what will be my nth array? What will be the nth term?
5 by 6.
5 times 6.
Nth term.
Yeah, the nth array is 5 by 6. You said that.
The next array is 5 by 6, but the nth array.
Oh, sorry.
No
N by
problem.
n plus 1.
Yeah.
Repeat it.
N by n plus 1.
N times n plus 1, right?
Oh, yeah. Okay.
Okay. Now, when you think about it, right? let's see. When I read it as a sequence, I want you to see this and understand. Okay, this goes a long way, not just for geometry. That's what I'm saying. Geometry doesn't really require it, but then you will find it so useful as you grow up. So here, see here, one. Um, okay, but here, okay, here it's a little different. You see, okay, one. Okay, so here it's an array. Okay, so this is correct. Your answer is correct. N times n plus one. But let's see one more. So you should be able to distinguish how to find it's a quadratic or it's n power of 2 thing. How about this? Okay, 3, 8, 15, 24. What is the nth term? 3, 8, 15, 24. This is your sequence. And now I'll leave it to you. You try. If you don't get it, then I'll help you. 3, 8, 15, 24. What is the nth term of the sequence? And you know what? Yeah, I'll also tell you how to use a calculator for this. Meaning these are extras which I can do during the summer. Okay. If it is the usual school day, I'll not be, I mean, if it is a usual school week, okay, I will not. I prefer not to go through all this. This is just extras that we can prove to be useful in the long run. You get it? Mm, nice one. 2 is 4 plus. Correct, Johan. That's right. So first of all, how to find? There is no common difference or common ratio. So I would go ahead and find 5. Then what is this? 5, 6, 7. This is 24 minus 15 is 9. Then what? 2, 2. Wow. This tells me that it is a second difference is the same, right? This is the second difference. This is the,
Quadratic.
yeah. So the pattern is quadratic. So your nth term, let me put it down first. Your nth term should contain some n square value. So the best way to find out this is what to do to find out if I'm confused, right? What I can do. Anyway, I need this, right? 1, 2, 3, 4. Let me erase these off. I found it's a quadratic, right? So I'll go ahead and try this one. 1 square plus 2. This is 2 square plus 4. What is this? 3 square plus 6. What is this? How is this related to 1? How is this related to 2? How is this related to 3?
Multiplied by 2.
Multiply by
2.
2. So n square plus that term n multiplied by 2. Make sense? This is easy ways, okay? But you know what? You don't need to go through this manual step. But you know what? Finding it, figuring it out manually really helps you, honestly. Okay, that's why we go ahead and go through this. But when it comes to calculator, do you know how to use TA84 calculator and get this? Do you know how to use do you know or you don't know? I just need answers.
No.
No.
Okay. Um, let's try. Yeah, even I am doubtful. So let's see. You'll see. I just need one of these numbers. Wait, TA84. Let me share my screen with you. Let's do it now itself so you guys know. Because that's what, if as I said, right, if it is school, I won't waste time on these. But why is my, I don't know. Okay, let me see. The Chrome TA84 I need to share with you, right? Give me a minute. Ah, I have it. Do you see my TA84? Okay. So here, oh my God, yesterday as well, I faced the same problem. Refresh the page. No, it doesn't go. The kids gave me another website for TA84 calculator. Yeah. No, I want a TA84 calculator, right? Can you help me find out a TA84? What, guys? I don't know. No. Oh, okay. Okay, this is better. This calculator is better. Okay. So here, edit stat calc is good. Stat, okay. Edit. Let's go ahead and type out 1, 2, 3, 4. How to go to L2? Okay. Now, can you tell me what are the values I gave you? Can you please tell me what are the values I gave you?
3, 8, 15, and 24.
3, 8, 15, 24. Now, let's go to stat calc. Let's go to linear what type of sequence was this? Quadratic, huh? What type of sequence was this now?
Quadratic.
Quadratic, okay.
Quadratic.
So see, okay, here, calculate, enter. Oh my God, you know why? What is not appearing? What is the problem? Anybody? What is the problem? I don't see anything here, right? Mode. Where is the start button? Something should be on, right, guys? What should be on here? Something should be on, right? I don't remember, honestly. Start diagnostics on. Now I go back. Stat, calc. If I go to quadratic, okay, enter, calculate. Okay. We have it. Okay, we have it actually. See, the value here is the equation should be what here? A is equal to 1, B is equal to 2. So basically, the expression would be what? I just plug it in here, guys. It gives me the equation, right? See, it gives me the equation. So it is 1x square plus 2x. That's it, right? For the nth term, you say it as n square plus 2n. Any questions? If you know these are very helpful.
That makes sense.
Yeah. So for linear, suppose, I don't know if I have linear examples. Let's see. If I have it, we'll definitely do. I want to do one more, which is hard. How about this? Do you want to try this one or something that has an answer? I would like to check so that you can do it. I don't have a nice example. Okay, anyway, let's see this one, the last one. I don't have the answer with me, but I would like you to try. 0, 7, this is easy. 0, 7, 14, 21, 28, 35. That is easy. Okay, seventh multiples all are there. Okay, let me go ahead and show you. Again, for linear, I'll show you once more. So if you had not picked how to use the calculator the first time, you can pick it up once more. Okay, so let me show you T84 calculator again. Why did I stop screen share? Okay, do you see my T84 calculator? Oh, this one is a bad calculator, right? Oh my gosh. You're still able to see Google Chrome? Guys, you have to let me know, right? I don't know. Are you able to see my Google Chrome?
We can see your
Calculate.
calculator.
Okay, good. Yeah, I know, but you're working, right? Okay, now let's go ahead. I'll go back to start, edit. I just want to clear everything. I can't clear. That's bad. Okay, I need to see how to clear. What do I do? Oh, wow. Quit. Okay. Start. I want to edit. Let's see. Clear list. Let me clear the list. See, there is a button, clear list. Okay, enter. Oh, it doesn't clear. Oh my gosh, that's not great. Okay, enter. Okay. Now let's go to start, edit. Okay. So now 1, 2, 3, 4 sequence numbers will be what? Multiples of 7, I told you, right? Multiples of 7 means it's a linear sequence, right? 7, 14. If you don't know, right, this is another way of calculating. 28. So you have 4 terms in the sequence. You want to find the nth term. Again, go to start. Start what? Calc. Then go to linear regression. Okay, L1, L2. We don't want to store the equation. We don't need to do. Calculate. You have this. So what does it mean? Something seems so wrong to me. So you can write the equation as this. Here, see, substitute ax plus b. 9.1x minus 10.5. Is that what it is? Something feels wrong to me. Wait, something feels wrong. Hold on. Edit. Start. Edit. Did I type it wrongly? 0. So, oh my gosh. It is 1, right, guys? 1, 7. That's why it went start. Let me go to what? Let me go to start, calc, linear. Something feels wrong to me still. What was the mistake there? Can one of you check and let me know, please?
Yeah, can you go back to the list? Oh yeah, because you have to
Oh,
put 0 for 0 and then
sorry,
1 for 7.
1 for 7. This should be 14, right? 21, 28. Okay, that's good. So start, calc, linear regression. That's all. I think this should work good. See, that's correct. So it is 7x. Makes sense? You just substitute ax plus b, you just substitute a equal to 7, b equal to 0. Any questions? So this is how you obtain your nth term using a calculator. Don't abuse this. Try to use your brain as well. Can I move on? This comes into logical reasoning, which is not important, but at the same time, you have to know. Can I move on? Okay, now let's go back. So you can do part 2 now. We did go over. Okay, you can sit and do part 2 at home. Part 5, what is deductive reasoning? I didn't go over that with you. I'll make sure your part 5 is not messed up, okay, before giving it to you. Now, what is deductive reasoning? This is the logical reasoning is divided into 2 different things, right? One is inductive, one is deductive. Inductive reasoning is observing patterns. Okay, observing patterns of what happens every Wednesday, what happens every day, like that. And then coming to a conclusion that this would happen the next day. Whereas deductive reasoning is just based on facts, rules, definitions, properties. You see? So it is deductive reasoning. So now let's consider an example of deductive reasoning. Every time Kennedy has skipped studying for a math test, she has gotten at least 6 wrong. Kennedy skipped studying for her math test today. She concludes that she will get 6 wrong. See, she is seeing a pattern, right? She's deducting from what she saw, right? Rules, facts. It's not based on, see, there is a rule given. Every time Kennedy has skipped studying for a test, she got at least 6 wrong. So it's a fact given to you. Based on that fact, can you conclude, meaning Kennedy is concluding that she'll get at least 6 wrong today, she skipped studying for her test. So this is deductive reason. This is see. Okay, I think I confused. Okay, I think I confused you a little bit. Let's see. Wait, I'll share. Are you seeing my notes page? Okay, so when it is based on a rule or facts, it's deductive reasoning. So let's put out inductive and deductive reasoning. So here, this is based on observation of pattern. This is based on observation of rules. Rules or facts. Okay. So there's a big difference between two. Now you see 1, 2, 3, 4. You're looking at the pattern. You're saying that the next sequence is 5. This, you're looking at a pattern that's happening. Okay. Similarly, Monday, school bus came at 7:10 for pickup at your bus stop. Tuesday, bus came at 7:10 for the pickup at the bus stop. So Wednesday, you're concluding bus will come at 7:10. What is this? This is, again, you're basing it on pattern that you observe. There is no rule that is stated, oh, 7:10, the bus is scheduled to come at this and this stop. Nobody has given you that. You just saw the bus came, then Tuesday the bus came, Wednesday you're concluding that the bus will come at 7:10. So this is also inductive reasoning. Okay, let me tell you an example of deductive reasoning. This one, let's see. How about this? Okay, there is a rule here, meaning it can be based out of facts or rules. So let me give you one example of deductive reasoning. How about this? Kyle is late enrolling for summer school. Okay, he will be assessed a late fee of $30. Kyle, if Kyle is late enrolling for summer school, he will be given a penalty of $30. It's a rule given. Now, Kyle enrolled late this summer, so he concludes that he will be assessed a late fee of $30. So this is based on a fact or some rule or facts or whatever given already to you. So this, in this case, becomes deductive reasoning. Any questions? Any questions? How about this? I really want you to be able to find out, please. What is this? You should be able to differentiate inductive and deductive reasoning. What is this?
Inductive.
What is it, ma?
Inductive.
Inductive.
Okay. Yeah, I think it's inductive. Is there a doubt? No, if there's a doubt, I'll clarify. Please let me know.
No,
Okay.
there's no doubt.
Okay. And how about this? Okay, how about this? Let's see whether you determine this correctly. I'll erase everything off. At Fumio school, if you're late 5 times, you'll receive a detention. Fumio has been late to school 5 times. Therefore, he'll receive a detention. Is it inductive or deductive?
Deductive.
It's deductive. Good job. So if there is a rule stated, then it's deductive. Okay. You know what? Early years, right? Or 5 years back, we used to have deductive reasoning. There were 2 laws again, philological or some laws and all we used to discuss. That no school goes through that. So I'm going to skip that. We are not going to do that at all. Okay. So you're going to complete the PDF assignment, the part 2 and 5 that was left out in logical reasoning for this week. Any questions on that? From the last week PDF itself, you can take it, but you're going to complete part 2 and part 5. Okay, now I really want to go ahead and show you, see, geometry as we move further will consist a lot of proofs. Proofs can be of 3 different types. Okay, geometrical proofs. Proof means you have to prove something. Prove line A is congruent to line B. Prove triangle ABC is congruent to triangle A dash, B dash, C dash. So anything requires proof. we will be learning a lot of theorems. You all know postulates or axioms are accepted statements in mathematics that do not require proofs. But theorems are statements that need proofs. Only with proofs, they become theorems, meaning if you have a statement, only when you prove it, it becomes a theorem. But if it is accepted as is without any proof, it is just a postulate or an axiom. Those are the two different ways of a generic statement which is accepted as is without proof is a postulate. Can also be called as an axiom. But what becomes a theorem? The same statement, when will it become a theorem? When only we have proofs. Okay, geometric proofs are quite important piece. It comes everywhere. Whatever topic you study, you'll have proofs. So here, the proofs can be of three different types. One is a two-column proof. The second one is a paragraph proof. The third one is a flowchart proof. Any questions, guys, still here? Dhruv, I'm not able to hear you.
Oh, I understand.
Okay. So we are going to, meaning each will come, okay? Three are different proofs, okay? But let's go ahead and try, meaning to write out proofs, right? You have to know a list of postulates at least. Okay. Some of the postulates we have already learned. Okay. You remember, let's see whether we know some postulates to write out proof. So first I'll discuss this. Two-column proof always consists of statement on the left side and a reason on the right side. We always, something will be given. You have to prove something. Both will be given. Hey, I give you this, prove this. If they give it to you like this, you'll have to write the statement on the left side. You have to start with the given statement. And then you start writing sequence of statements, meaning sequential order it has to flow. Meaning a person who does not understand anything in geometry should be able to understand, hey, given, from the given, you have to prove what to be proved. This is what is the final statement for a proof. Meaning from given should be your first statement. You have to start with the reasoning. From there, what next? Because this is given, this is possible. You have to write and write a reason. Similarly, keep writing statements and reasons, and at the end, your last statement should be what has to be proven. This is a two-column proof. Paragraph proof, exactly the same thing. You convert it into a paragraph and write it down as a paragraph. Similarly, the same two-column proof can be put down into a flowchart. I'll show you all, not right today, but I want you to work on two-column proofs extensively today, this week and next week if possible. Can I move on?
Miss Priya,
Yeah.
the electricity went off. Could you explain this whole thing to me again?
I'm going to keep going a little bit faster. Geometric proofs can be two-column proofs, paragraph proofs, flowchart proofs, right? Now, two-column proofs can be statement and reason. Statement on the left side, reason on the right side. Okay. So why? What is this? Usually, you're given some statement. Okay. You have to prove one statement. If you prove something, it becomes theorem. If a statement is accepted as is, then it is a postulate, or even it can be called as an axiom. This one we already discussed in previous classes. But when does a statement becomes a theorem? When it has a proof. You will be learning a lot of postulates and a lot of proofs, a lot of theorems in geometry. Whenever we come across a theorem, you should all see, frankly telling you, you should always make sure you know the proof for the theorem. But school level geometry doesn't. School level geometry, whatever you learn doesn't necessitate you to know the proof for the theorem. You just learn the theorem, you just by heart it, memorize it. That's the way people go. But it's always nice to see whether you are able to write a two-column proof for your theorem. That is what is nice. That is the best way of learning. But generally what has happened now is we learn theorems, we by heart it. And for some we learn the proofs, for many we don't. But if you're really dedicated, it's nice to write a two-column proof for every theorem you study in geometry. Okay, can I move on?
Yeah.
Avyu, did you catch up?
Yes.
Okay, good. Okay, let's go ahead. How about this? Did we algebraic equality? Did we do this? I feel like we did this. Algebraic equalities. See, I have discussed this, right? A plus B equal to B plus A. Have I discussed this with you?
Yeah.
This is, what property is this? What property is that? A plus B equal to B plus A?
Identity.
It is it is an identity, but what property is that? Okay, I'll discuss again. I remember discussing it in this class. Let's see. Wait, let me show you. I'll go over it again for sure. But I think after completing algebra, before getting into geometry, we did do this. Okay, now let's go ahead. This is the list. This was it. See, if we want to write proofs, right, you should be able to remember this. Let me show you what were they. This we did actually. I don't know how many of you remember, but I think some of you were not there in the class as well then. So here, when we say, let's say, you know A equal to B given. If you have A equal to B, you can say A plus C equal to B plus C. Why? You added C on both sides. That is called addition property of equality. When this is given, I can as well say A minus C equal to B minus C. That is subtraction property of equality. Given this, I can as well say AC equal to BC. Why? I multiplied C on both sides, right? So given this, I've proven this, meaning I have this due to this property, addition property of equality. Why are we learning all this? See, the thing is, you are saying this, right? Now, this can be a statement. In your reasoning column, you can reason it out as addition property of equality. Okay. Here, if you write this as your statement, you can write subtraction property of equality. Am I making sense? Avyuk, am I making sense?
Yeah.
Yeah, suppose if I write a statement like this on my left side, I can write multiplication property of equality. Like that, A by C equal to B by C, division property of equality. Suppose if I have suppose if I write, I have three numbers, three real numbers. If I say this is equal to AB plus BC, what is this? Distributive property of equality. You see? Similarly, let's go with this. This is if A is equal to B, the other way B is equal to, then B equal to A. Suppose if they give you given A equal to B, then the next line you're writing, meaning proof, the line number 1 will be A equal to B given. From this, it has to be a logical sequence of statements. When you come to a proof, it is just a logical sequence of statements that follows. I can say B equal to A. From A equal to B, I can say B equal to A. Why? What is the reasoning? Symmetric property of equality. Does it make sense?
Yes.
Then, yeah. Then for any real, see, this is just examples, okay? Examples in algebraic relationships. However, this is applicable for a line segment as well, more into triangles, all that we'll be solving. But for now, just understand some basic properties, some basic postulates to write out your proofs, okay? Reflexive property means sometimes in triangles when you solve like this, A, B, C, D. Now, see, AC is equal to, see, this line segment is common to both the triangles, right? So there on see here B equal to A or A equal to A. See, these can be substituted. In triangles, it will become a line segment. In algebra, we say if A equal to B, B equal to A is symmetric property of equality. Reflexive property means A is equal to A. For any real number A is equal to A. Similarly, the last two are very slightly different. What is this transitive property of equality? Suppose if you confront something like this, A equal to B, B equal to C. Angles you can come across. You can say one angle is equal to angle 2 is equal to angle 3. Then what can you say? Here, if you say A equal to C, A equal to B, B equal to C, then A equal to C. First and last you're doing, right? This is called transitive property of equality. Make sense? Then if A equal to B, A equal to C, see here there is a subtle difference between the two. B equal to C. This is substitution property of equality. Do you see what? There is a subtle difference between the two. Transitive means A equal to B, B equal to C. Then you say A equal to C. Here A equal to B, A equal to C. Then you say B equal to C. Then that is substitution property of equality. Okay, for now you don't need to worry much. Okay, and the other a couple of important postulates are angle addition postulate, segment addition postulate. Angle addition postulate. Let's say a postulate means I'm going to say a statement you're just going to accept without proof. Remember that. Postulate means I'm going to say a statement without proof you're going to accept it. Okay. So how about this? Angle ABC. How I am writing it in geometry. See here. Angle ABC will be equal to angle ABF plus angle FBC. What is this? What postulate is this? This is called the angle addition postulate. Or I can say angle ABC is equal to angle 1 plus angle 2. You know this already. You know the postulate. See, as soon as I see the diagram, you'll know 1 plus 2 equal to the bigger angle. No, everybody knows. But the problem is when you write the proof, you will have to write the reason on the right side. If ever you come across things like this on the right side, you'll write the reason is angle addition postulate. Similarly, when I see this line segment AC, you clearly know the line segment AC is AB plus BC, but you're a geometry student. So on the left side, you'll write this. On the right side, you'll say, hey, this is segment addition postulate. Any questions? Any questions? Shreya, you're following, ma?
Yeah.
You're following? Okay. Now, okay, suppose let's say they give you this given. Okay. I want you to be able to be comfortable with when to write what statement, what reasoning as well. So see, this algebraic property of equality, you'll be a little clear. It's easy to write. Segment addition, angle addition, you now know. What other things you know? Let's see. Suppose okay, how about this? Okay, let's see this one. Let's see this diagram. Let me draw it this way. Okay, now this is FE. Let me draw it this way. FEC. This is angle 6, angle 5. What else? Maybe we need this. Yeah, we will need this. ADG. Okay, let's see this. Okay, here, when you look at the diagram, okay, I can say ABE is a right angle. If I say if angle ABE, I'm giving you that ABE is a right angle. Okay. Then as a part of the statement, right, given that AB is a right angle, because I marked it in the diagram. Okay, so ABE is a right angle given. Reason I will say given. Okay, now as a continuation of this, right, I can say one more statement. I'll say measure of angle ABE is equal to what? It's very simple, guys, meaning you already know what is a right angle. But in geometry, when you write proofs, the problem is you will have to put it out and say a reasoning. So what is the measure of ABE? Guys, ABE is a right angle. I've already marked it here. So what is the measure? Is
90.
equal to 90 degree. What is the reason? Definition of right angles. That can be reasons. You get it? Did you get it?
Yes.
Okay, now let's go with one more. Can I go with one more? What else I can say? I can give you. I can give you examples so that you get used to nothing else. We have not started writing any proofs. Would be nice if we can start writing proofs. Let's see. I'm going to give you a few more for you to become comfortable. How about this? Okay. How about we have angle 2. I don't know how is that. Okay, angle 2. This is better. I'll mark it like this. Okay. From the figure, I can say I'll mark it like this. Okay. In statement, I write angle 2 is congruent, means same size, same shape. Anish, you belong to the class. Angle 2 is congruent to angle 5, right? And angle 2 is congruent to angle 5. What else? And angle 1 is congruent to angle 5. This is marked given, right? Both are given. I'll write it in two statements. Angle 2 is congruent to angle 5. Angle 1 is congruent to angle 5 given.
Wait, Miss Priya, I have a
Yeah, ma?
question. Wouldn't that mean that angle 6 is congruent to them all?
Angle 6 is congruent to them all. Yes, it means that is another theorem. I'll come there. Very good job though. Okay, now I can say angle 2 is congruent to angle 1. What is this property called? You tell me, guys. Something from here.
Symmetric property of
Is it symmetric, ma? Symmetric is only two angles. Angle 2 is congruent to angle 1, then angle 1 is congruent to angle. That is symmetric. You're comparing 1 and 2, then 2 and 3, 1 and 2, and then
Is
see.
it transitive?
Transitive property of equal. Transitive property, that's all. You got it like this. You need to be comfortable in writing reasoning. Can I move on?
yes.
I'll give you maybe one more example, okay? Okay, how about this?
Priya, I have just a quick question after class.
Yeah, sure, ma. I'll finish as well. I'm not going to take much of your time. A measure of angle 2 plus measure of angle 1 will be equal to measure of angle ABG. What is this? What is the reasoning here? What is the reasoning here? Should I write it big or what, Dhruv? You're not able to see?
Me?
Mm,
Wait, let me. It's fine.
okay. Anish, do you belong to this class? Okay, go ahead. Measure of angle 2 plus measure of, okay, let me mark it up for you guys. Because I feel like, Johan, what is this property, Johan? Measure of angle 2 plus measure of angle 1 will be this. What is it? What is the reason?
Is it like the angle addition?
Yep, angle addition postulate. See, once you get a hang of this, writing proofs is so easy. To get a hang of it, you should know what to write in statement. Writing statement is even easy, but writing reasoning is the first thing people suffer, kids suffer, and I don't want you to suffer at all. In the sense, once you get a hang of these postulates, once you have memorized this, then it is easy to get out of your brain. Okay, so how about this? Why I deleted that? That's not great. Okay, how about, let me give you one more statement. Let's see where we are. Are you comfortable in getting the reasoning is what you need to see, okay? After school reopens, I might not spend time on proofs at all. I'll keep writing proofs, okay? So now let's see. Okay, now this is good. This is, see, the reasoning can be definitions, algebraic properties of equality, postulates. Okay, reasoning can be even definitions, definition of right angle. See, here, this is a right angle, right? AC is a line segment. Now, if I want to prove EBC is 90 degree, EBC is a right angle. Okay. And next line I say EBC is equal to 90 degree. Why? Definition of right angle. Okay, that is a reasoning, meaning this side I'll write, here I'll say definition of right angle. That is the reason. Now let me give you one more. Angle 1 is, oh my god, angle 1 is supplementary to FBG. Okay, now then measure of angle 1 plus measure of FBG will be equal to 180 degrees. What is the reason?
Definition of supplementary.
Yeah, definition of supplementary angles. You all know supplementary means the two angles add up to 180. So definition of supplementary angles. Am I with you, Dhruv Nayak? Am I with you?
Yes.
Okay, good. So if I, you know what is the definition of complementary angles, right?
Yeah.
Okay, good. Let's see this one. Okay. Okay, I want you to be able to write the reasons at least. Okay, let me show you a very simple proof and then let you grow. Very simple proof, okay? So this is what I'm aiming at, okay? I'm giving you this. Given Q is the midpoint of PR. Q, it's a very simple one, whatever we have learned till date. Q is the midpoint of PR. Okay, I'll give you a diagram as well, okay? Q is the midpoint of PR. Okay, and I have one like this S. Okay, now QR is congruent to PQ. QR is congruent to RS. I'm sorry. QR is congruent to RS. QR is congruent to RS. Now you have to prove what? I've given you two statements. 1, 2. To prove PQ equal to RS. PQ is congruent to RS. Congruence, please. This is the symbol for congruence. This is the symbol for similar. Okay, as we go with geometry, I keep telling more important notations as well. Okay, this is congruent, that is similar.
Wait.
Congruent means, yes,
Wait.
ma.
Do we like say it in the chat or correct?
Let's discuss, ma. Let's discuss, please. Statement, reason. Go ahead, Dhruv. You want to start? Always your first statement is what?
Given
Given. So what can I write?
the
Q is the midpoint. That's what is given, right? So don't think more, meaning people have starting trouble in writing proof. Given is your first starting point. Q is the midpoint of PR, given. Then what else?
UR is congruent to RS.
Wait. From this given, it's a logical sequence of statements, right?
Yeah.
Don't keep on writing given. What can I, Q is the midpoint of PR means, what can you tell about?
UR.
PQ is congruent to?
QR.
PQ is congruent to QR. What is the reasoning here? We have utilized just this. What is the reasoning here?
Segment additional postulate.
There is no segment addition, right? I'm not adding any segment yet. Q is the
Okay.
midpoint of PR. I'm writing PQ equal to QR. Why would I say that? Definition of midpoint. It's so simple, you would not even have thought about it. But definition of midpoint only makes you say this, right? Make sense?
Yes.
Okay, now what to do? We have not used this, right? Can I start writing that? QR is congruent to RS.
So that's given. So you can use
Given.
it. transitive property of
What can I use? Tell me, tell me, tell me.
the transitive thing.
Good job. So what can I write here? Statement.
PQ is congruent to R.
Exactly. PQ is congruent to RS. That is what is to be proven. See, what is the reasoning? Transitive property. This is a very simple proof on what we studied. Make sense? You cannot take anything for granted. Yes, you and I know it so well, but you have to write that down and say, hey, this is the definition of midpoint. Make sense? Okay, I'll stop here, guys. We learned enough today. Meaning, what did we do? We studied deductive reasoning, logical, inductive reasoning. I just showed you how to find out between three models in the calculator and just like that from your brain. And then we went into proofs. We started writing proofs, which is an achievement considering, meaning left to me, it is an achievement. So if you can keep through this and please start writing proofs, you'll find it so awesome in geometry when school starts. Any questions? Any questions? Okay, if you don't have questions, we'll log off.
Goodbye.
Miss
Okay, bye
Priya.
guys.
Priya.
Yeah. Hey, but before you log off, yes, if you have questions, stay. But before you log off, do you all know, meaning if you're interested in working out more outside the homework given, you stay. Rest of you log off. Meaning no force, no pressure. I'm going to talk about alchemist, Johan. You can log off. If you don't have any questions, you can log off. I think you know, right? Because you attend the other class, right? Geometry. No, the algebra.
Yeah, I have a question after.
Yeah. Go ahead.
Bye, Miss Priya.
Bye, guys. If you I'm going to show you a website where you can do more problems if you would like to. Okay. But if homework is itself good enough, you can log off. No pressure at all. Yes. Go ahead, ma. Go ahead, Johan. What is your question?
It's about last week's homework. I didn't really understand your for part two, number three, in the area challenge. I think what you've done for your answer and your answer key, you've done the Pythagorean theorem, but like one.
No. Wait. Let me see. If it
Okay,
is
yeah,
wrong,
sorry.
it's wrong. Wait. I am going to bring up. Because if it is wrong, it's wrong, right? Let me see.
Okay.
You see my screen?
Yeah.
Where? Which one do you want me to see?
The area perimeter challenge assignment.
The area perimeter.
Yeah, it was that one.
Uh-huh. What
Yeah,
is your
so
question?
in part two, which is like the one after
Part 2. Yeah.
yeah, on question three, on it, I
This is
didn't really
definitely
understand.
question is incorrect.
Yeah, okay.
Question is incorrect. I'm sorry about it. They
Okay.
have missed to give you that this is 12 feet.
Oh, okay.
Okay. This one is correct though.
Okay, yeah, I got that one.
Very nice, Johan. Very good find. They have forgotten to given that this is 12.
Okay.
Make sense?
Yeah.
This is 12. This is 12 or this is 12. Whatever. Was some measurement given is they have missed to give.
Okay.
Okay. This one is correct. You got it?
Yeah.
Okay, good. I'm sorry about it.
Yeah. Okay.
Any other questions?
No, I'm fine for now.
Okay, good.
Miss Priya.
Yes.
My internet was unstable, so I couldn't really catch up with your inductive and deductive reasoning part meeting.
Absolutely. No, you can watch the recording, ma.
Okay, sure.
Okay, that really helps me. You got it?
Sure.
Okay. The recording is there.
Bye.
Let me know if you, yeah. Go ahead, W. What is it?
No, I was saying bye.
Bye. Have a nice time in India.
You too. Have a nice time.
You
Bye.
too.